All right, 8th and 9th grade, are you ready for test? But maybe we better check study guide before you do test and see if you got those answers right. And if you got those answers right, I'll assure you you're ready to go for test. So, on study guide 15, the first is two terms that you need to define. And I'll just tell you, you know how many terms are on the test. There's two. They got both of them on there. Electromagnetic wave, a transverse wave composed of an oscillating electric field and a magnetic field that oscillates perpendicular to the electric field. So it's perpendicular is to each other. And there's a picture back in your lesson of those two oscillating. You can look at that. The blue and yellow, I think, are the colors they use. Gives you a good definition. B's answer is a law of reflection. The angle of reflection equals the angle of incidence. That's number one's answers. And yeah, thank you for most of you are getting those correct. Okay, most of you are doing a great job on that, and thank you for that. And study those again for this test. I am going to go to number 2, and you actually have 3 answers. You explain the theory of light and the particle theory, and you explain the wave theory, the particle theory, and the quadromechanical theory. Okay, so the wave theory is like this: is light views as two transverse waves, one made of an oscillating magnetic field and the other of an oscillating electric field. Okay, the wave is the one magnetic and the other, and they're oscillating. The next theory, that's the wave theory. The particle theory of light views a ray of light as a beam of individual particles called protons. Okay, so it's individual particles of protons going through a beam. That is the particle theory. And then the quadromechanical theory says that light is both a particle and a wave. It's made up of individual packets that behave like particles, but the packet is actually made up of a wave. Okay, so if I would put this in my own words, the one is like a wave that's traveling. The other is little particles that are traveling in a beam. And then the quadromechanical theory takes both of those two and puts them together. And it says it's little particles traveling in a wave. Now that's my simple explanation of the two. You will need to know this for test. And number 3 says sound waves cause air to oscillate. What do light waves oscillate? What do light waves oscillate? Light waves oscillate a magnetic field and an electric field. Number 4, what does Einstein's special theory of relatives say about the speed of light? It says nothing with a mass can travel faster than the speed of light. So nothing with a mass. You want to know what the fastest car is, you want to know what the fastest plane is, the fastest whatever. Well, the fastest thing with mass is light. Can't beat light. Number 5, light travels through water and suddenly breaks at the surface and travels through air. Did light's speed increase or decrease or stay the same once it left the water? Okay, you need to understand this. The light speed increased once it left the water. Increased. And number 6 is you are to order the following colors in terms of increasing wavelengths. And you put them in this order. You should have put violet, green, yellow, orange. Violet, green, yellow, orange. Number 7, you again was putting in inverse proportion. You should have put orange, yellow, green, violet. Should have put them backwards from what you did in number 6. You'll need to understand this for test. Okay, if you don't understand this, you think of a rainbow, and that the longest one is on the outside, and the shortest one is on the inside. And you remember Roy G. Oh, I'm just getting ready to give you an answer. Hang on to that one. Number 8. Do radio waves have higher or lower frequency than invisible light? What about X-rays? Radios have lower frequency and X-rays have higher frequency than light. And look back at your example. You have that example. I don't even know exactly which page that is. And you will need to know that you will need to study that well. I should have had that, looked that up before now. Yes, it's on page 372. You need to know that spectrum, figure 15.3. Number 9, it asks, infrared light is given off an object that is losing heat. The human body is almost always losing heat to the environment. Why then don't human bodies glow at night? Woo, how you like that? Since they are emitting light. Okay, infrared light is not visible. Okay, we're not giving off infrared light. Infrared light is not visible. Even though human bodies constantly emit infrared light, we cannot see that happening. There are special devices that you can get that do indeed detect the infrared light and the human body emits. This allows you to see living organisms and other hot objects even in the darkest of night. So you can get a certain kind of instrument that will do that, but our naked eye can't see that. Number 10, light hits a mirror making an angle of 15 degrees relative to the line drawn perpendicular to the mirror surface. What angle does the reflection light make with the same line? Okay, this is very important that you get this concept. You look here at 15 degrees, what degree does it reflect? Identically the same. It's 15. Reflecting light always is whatever angle you shine at, that same angle it reflects away from. Okay? Reflection light also makes 15-degree angle relative to the line. That's the reason you can stand here and look down in the mirror, and the mirror reflect down and you can see your toes. Number 11 is yes. In the following diagram, will the man see his foot despite the fact that the mirror does not reach the ground? Yes. You know why? I just got done explaining to you. He looked down and then it reflected down to his foot. That was 11. Number 12. When light travels from one substance to another, what two things happen in the direction the light rays travel? And the two things that happen, light rays can be reflected or refracted. Reflected, refracted. And number 13 is the light will bend towards a perpendicular line. It asks a question about a scientist or a physicist is experimenting light rays. Will the reflection ray bend toward or away from that line? It will bend toward the line. And number 14, when light travels from water to air, it bends. This has caused your mind to form a false image of the object in a slightly different location. So that's the reason we go back to this old question again with the fish swimming in the water. It bends, light bends. And so when you see the fish in the water and you want to hit it with an arrow or with a spear, you got to spear in front of it. If you spear right at the fish, you will miss it. Well, you might miss it in front of the fish too, okay? Let's get that straight. But the bending of light in water fools your eye. So you always want to shoot in front of it. Let me see here. I was fishing and I lost which one. Number 15. It asks, in order for you to see a rainbow, what three conditions must be met? First one, there must be water droplets in the air. The sun must be shining from behind you. And third, the sun must be at a certain angle or height in the sky. So the sun really needs to be down low, shining behind you, up on the rain droplets. If the sun's straight up and down, it won't work. So you need water in the air, sun behind you, and the sun must also be at the right angle. 3 answers. Number 16, what's the difference between a converging lens and a diverging lens? And a converging lens causes light rays to bend, so the converge to a single point. Bring the and a diverge is just the opposite. It causes lights to bend away from each other. I think you would have learned convex and concave earlier, and they call it here converging and diverging. 17. Lens is a covering lens and lens. Whoa, wait a minute. Which of the following lenses is a converging lens and which is a diverging? Okay, A is a converging and B is a diverging in your examples. Number 18, the eye focus light by changing the shape of its lenses. A camera focus lights by moving the position of the lens. Okay, what special way does a light focus concerning the way a camera focus lights? Okay, and the eye focus light by changing the shape of its lenses, whether you have a flat one or a round one, and then the camera focus light by moving the position of the lens back and forth. Number 19 says, suppose the cone cells on your retina, that sensitive red light no longer work. If you look at a white piece of paper, what color would it appear? If you looked at a red piece of paper, what color would it appear? You need to kind of get this, a little bit of concept of this here. If you looked at a white paper, it would appear to be blue, green, or cyan. C-Y-A-N. And if you looked at a red piece of paper, remember that experiment you did with the cross, the red cross and the white sheet of paper? And that's where it comes in here. And if you looked at a red piece of paper, the red paper would appear to be black. And let me just talk about this just a little bit for test. You have on page, back page here just a little bit, yes, on page 390, you have an example of red, blue, and green, and when you mix those, you get certain colors. You have to know those for test. When you mix red, blue, and green together, you have white. All three of them. Blue and red make magenta. Green and red make yellow. And green and blue make cyan. You need to know those for test. And then you turn to the bottom of page 391. You got the same example again. You got yellow and cyan make green. And then you have magenta and cyan make blue. It's just reversed, okay? Not real hard, but you kind of, if I can say it in plain words, you kind of need to know that for test. Number 20 is, thus it absorbs red, yellow, orange, green, blue, and indigo light. Number 20 says, a shirt is dyed so that it looks violet. What colors of light does a dye absorb? Okay, it absorbs all the colors except violet. And number 21, a cyan dye is made of a mixture of substances that absorb all light colors except blue and green. If you took a piece of cyan piece of paper and placed it in the dark room and shine red light on it, what would you see? What would you see if you shine green light on it? Okay, in the red light, then the paper would look black. And when you shine the green light, the paper would look green. See how I told you how to kind of get a picture of how these colors work? All colors except blue and green will absorb any red light shown on it. As a result, no light will make it to your eyes. In the red light, then the paper will look black. And when you shine the green light on it, the green light will be reflected. There will be no blue mixed with it, though. There would be no blue to mix with it, though. In the green paper, the paper would look green, yeah. All right. If you have any questions, you call me. Enjoy doing your test.